Hello students, welcome back. How are you? I hope you're all fine, healthy, wealthy and strong. Okay, so we were discussing this chapter probability and we find out what is the meaning of probability. After that, we understood how we can have the empirical formula of probability. Before that, we studied about the different activities. We performed activities, we made some tables and we calculated a fraction, and that fraction we call it that this will give us the probability of something, of having an event or not having an event. Okay, when we were calculating the probability of these things in our activities, one thing that you have to be focused about, whatever values were coming were in some 0 point and something like 0.5, 0.46 or 0.23, maybe 0.35. that means there was no value which were like 2, 5, 10, 100, 200. So that was not the range. Okay, so you can say that the range of the probability is something like it was not in negative, it was not in a very big number in positive, so it was in 0 point something and something. Okay, we will talk about this, that what will be the range of probability. Okay, so we will be talking about that, but before that we are going to solve some questions. In the meantime, when we will be solving some questions, we will be finding out that what will be the limit or what will be the range of probability. Okay, what will the value range of the probability. Okay, so let's start with the first question. Before that, let us revise the last time that we have had the formula of it. Okay, what was the formula? The formula was PE, probability of happening this event, okay, is equals to number of trials. This is trial. Okay, so mark it, trials in which the event happened, divided by the total number of trials. Okay, when we were performing the activity, I have told you to toss the coin 20 times. So that means trials were in total 20. Now the total number of trials, the number of activity, the number of what you call it, trial we are performing. Okay, the number of times you are doing the process again and again is your trial. Okay, so this is your trial, that was 20. Now number of trials in which the event happened. Now event, what was the event? If I am tossing a coin, then there will be two events. Whether it will, that means the possible outcome basically. So the possible outcomes, what can be done? Whether it will be head or it will be tail. Okay, so head or tail. Now you are not going to do this like okay ma'am, maybe the coin will will be stand like this. No, that's not a real criteria. We are talking about the ideal condition where it will be either tail or head. Okay, so there are only two outcomes. So examiner may ask us about the probability of having head. Okay, so in that case the event happened is what? Having head. Okay, and if it's examiner, if examiner or the question is asking you for the tail, then the event will be the tail one. So here we will be having the number of trials in which we will be getting tail in the case of when the examiner have been asked about the tail outcome. Okay, so outcome which is asked, okay, or outcome which is it's like a indirect method of asking that okay, number of trials when tail is not coming. If tail is not coming, then head is coming. Okay, so if tail not having that event, if you are having in question not having that event, that means the another event. Okay, another remaining event. Now if you are talking about a dice, you play with that. Okay, you play Ludo. Okay, so then you'll be having 1, 2, 3, 4, 5, 6. Okay, 6 outcomes, whether it can be 1 on dice, whether it can be 2 on dice, whether it can be it is not a dice. Okay, so it can be 3 on dice, it can be 4, it can be 5 here, and it can be 6 too. So there are basically 6 outcomes. Now, if the examiner is asking you that you have to talk about only whenever the 3 comes into the picture, that means he's only asking about, or she's only asked about this particular outcome, this outcome. Okay, so the number of trials, when you're getting this 3 on the dice, you'll be having it here, right? So here the possible outcomes are, in the case of tossing a coin, that were only 2 outcomes, having head or having tail. Now in the case of dice, it will be 1, 2, 3, 4, 5, 6. 6 possible outcome can be here. Okay, so it is a difference between have the outcomes and the number of outcomes. Okay, so this is clear. Now about the question, the first question we having, a coin is tossed 1000 times. Okay, we were talking about a group activity. If you are assigning your 9 friends and be also working, and you will be also working on that, so you will be, it makes you 10, a group of 10 friends. Okay, now you'll be tossing, each will be tossing the coin 100 times. Okay, and having 10 of it, that will make his 1000 times. So you can perform a group activity of tossing a coin 1000 times. And when you add up all these result of head and tail, because the possible outcome of this coin is either you'll be getting a head or getting a tail. And when you added all these outcomes of getting head, only head. Okay, so let's suppose the student, or you can say that your friend number 1, this is you, okay, and this is friend number 1, friend number 2, friend number 3, and similarly friend number 9. Total will be 9 these friends and this you. So these outcome of yours, you add them all, and you will be getting what? Head 455 times. The total number of trials is giving you 1000 times, because a coin is tossed 1000 times, right? Okay. Now tail, similarly when you are adding these, because you are having some data, some numerical data for the trial and getting it to be tail. So your friend, let's suppose he got 50 number of heads, he got 45 number of tails. Okay, and then your friend number F5, let's suppose, having 45 number of tails, and when you sum it all, okay, you are getting some 49 number of tails. When you sum it all up, then you will be getting a 545 as your result. Now the question is, compute the probability for each event. Now complete the probability for each event. First understand what can be the events. First thing, it can be a head. So event number 1, it can be a head. Second thing, it can be a tail. That means the event number 2, it can be a tail. So we are having 2 outcomes, that means we are having 2 events. So talking about the solution, probability of having that event, what is that? Number of trials having an event upon total number of trials of that activity. If we talk about the first one, probability of getting ahead. Okay, probability of getting ahead is equals to number of trials having outcome as head divided by total number of trials. Whether it's going to be head or whether it's going to be tail, we know for sure that number of trials, total number of trials is going to be what? 1,000, right? So you can here solve it further, that will be equals to number of trials having outcome as head you got 455 divided by 1,000. Understood? Now that is going to be 0.455. This is your answer. And we have also discussed this, that as you will be increasing the number of trials in case of the coin, and you are going to toss it and you are having two outcomes, you are tossing one coin, head and tail. As much as you are going to increase this the number of tossing or number of trials, you may say, the value of it, the value of probability will be going near and all nearer to the 0.5 value. So you can say it here, you can see it here that 0.455 is very near to 0.5. Okay, is very near to 0.5. So here you can see it, right? Now the second thing, the second event is probability of getting a tail will be equals to, here P will be equals to number of trials getting a tail upon total number of trials. Students, it is very important to write the formula, whether you are you remember it all by all your heart, but it's very important in your examination to first write the formula and then put the values. Okay, that will be equals to 545 by 1,000, and that is going to be 0.545. I also made this clear to you guys that 0.545 in a daily life you want to use this, that how you are going to say what is the probability of having it. So you can just multiply it. It is not the part of this question, student, be very careful about it. Probability is answer of yours is this, but if you want to change it into a percentage, then you are going to multiply the 100, giving it 54.5%. So there are 54.5% chances of something. Okay, this is the way you get it, right? Okay, now you can jump to the next question, because this question has been solved. On one page of a telephone directory, there was a telephone directory. Okay, in old times you all used to have this for a telephone directory where we used to have a particular diary, and in that diary all the numbers of all the cities were there with the names of the persons who they belong to. Okay, so from that time we got a telephone directory, and there were 200 telephones numbers. There were how many numbers? 200 telephone numbers. The frequency distribution of their unit place digit. Unit place digit, that means if someone's having a number, okay, you are given with a number. So 25828 if this is the number, then the last number is 3 here. Now in these 200 numbers, you're getting last number digit as 0 in 22 contacts. Out of 200, in 22 contacts, in the last digit were 0. Last digits were 0 in the 22 contacts out of 200, right. Last digit was 1 in 26 contacts out of 200. Last digit was 2 in 22 phone numbers out of 200 phone numbers. Okay, and similarly this is true for 9. Okay, because you'll be having 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, only 9 numbers here. Okay, now what is the question? The question is without looking at the page. You don't, you just don't look at the page and count it. Okay, you have to, the pencil is placed on one of these numbers. What we did, we just opened it. Okay, we just closed our eyes and just had our pencil on some number. Okay, and that number, that telephone number is having a last digit. That last digit were, the number is chosen at the random. What is the probability that the digit in its unit place is 6? That means if you are having this, maybe this is that number or any number which is having its unit place as 6. So what will be the probability? Okay, you're given to the table, you're provided with the table, and that makes it so very easy. Okay, you have these digits as 14. You're having 14 numbers in that particular directory. You're having 14 numbers that are having last digit at 6. 14 numbers. Okay, out of 200. Out of 200. So that will exactly be the probability or not? Right or wrong? Okay. So now let's do this question here. So probability of that event is equals to, again, number of favorable outcome, you may say, or what we have, number of trials having last digit as 6. It was asked as 6. Okay, and total number of trials. Total number of trials. In this particular case, that is going to be, because the number of trial is 1, that is going to be total numbers in the directory. Okay. Now, as far as the question is concerned, you have 6, 14 times. Okay. So 14 upon 200, and that is making it 7 by 100, and that is going to be 0.07. That will be your answer. There is 0.07 probability of having it. If you want to calculate in percentage, you may say that 7% chances are there. 7% chances are there. Okay, so this is the way it will be done. So that is going to be your answer. Okay. Now the question is done. The next one. 50 seeds were selected at random from each of 5 bags of seeds and were kept under standardized conditions favorable to germination. Okay, there were 5 bags. There were 5 bags. These are the 5 bags. 1, 2, 3, 4. Okay, only 4. So here we are having 5 bags. In these 5 bags, you are having some seeds. Okay, many seeds. Okay. Now, after 20 days, you use a standardized condition so that you know, you have put the seed, so they have to, you know, germinate, and for that you put some favorable conditions in that. Now after 20 days, after 20 days, the number of seeds which had germinated in each collection were counted and recorded as follows. In the first number, this first number was having 40 number of seeds which were germinated. In second number bag, that was 48. In third number bag, that was 42. In the fourth number bag, there were 39. In the fifth number bag, there were 41. Okay, so this was the scenario. Now these 3 questions has been asked to you. First, more than 40 seeds in a bag. Okay, second, 49 seeds in a bag, and the third is more than 25 seeds in a bag, more than 35 seeds in a bag. So these are the 3 questions. I have given you the idea. Okay, and we are going to solve this question in the next lecture. I am just giving you, briefing you this idea that how will we calculating it. You are having these number of 5 bags. So total number of outcomes that can become are 5. Okay, and out of 5, if you are having more than 50 seeds in a bag, this condition if you are having for the first one, so more than 40, that means 40 will not be counting. 48, okay, it can be count. 42 can be count, it will not be counted. 41 can be counted. So there will be 1, 2, 3. So in 3 out of 5, and that will be going to be a probability. Now you can count it. Okay, in the second number, 49 seeds in a bag. 49 seeds in a bag. Are there any bag you're having 49 seeds? 49 seeds? No, in no bag. Okay, so you can just answer it 0 out of 5 for the second one, and that is going to be 0. Okay, in the third, more than 35. Yes, more than 25, more than 35, more than 35, more than 35, more than 5 out of 5, and that's going to be 1. So here I'm going to have some answers. First answer will be 0.6, I guess so. Okay, yes, 0.6 for the first. For the second, I am getting a 0. For the third, I am getting a 1. And my dear students, the maximum value is 1. The minimum value is 0 for probability. There is no value less than 0 or more than 1 that can be possible for the probability. So the range of probability is 0 to 1. Now we are going to solve this question. We will talk about this range very in very detailed way, but not in today's lecture. For today it's fine. Okay, we are finishing this lecture. In next lecture, just try to do this question on your own, solve this. I have given you actually proper hint, and we have just solve it, but try to put it in some language, and we'll meet in next lecture. Okay, take care, bye bye.